Hi, this is Joe Canary again. In this screencast, I'm going to show you how to use code coverage analysis to determine the quality of your testing. I'm going to use a plugin called EclEmma to do so. To find EclEmma, I went to Google and I searched for EclEmma, and I found this web page. I cut and pasted the update site listed here, and I went into Eclipse's Install New Software, and I added that site to the list of update sites. So if I choose that update site and ask it to install that particular plugin called EclEmma, click Finish, it'll download the plugin, install it, and suggest that I restart Eclipse, which is always a wise thing to do. Now at the moment I'm doing this in my standard workspace, which is where I'm doing my homework and the answer keys. It's usually wiser to do this in a clean, untouched workspace. I do say OK to the unsigned content warning because these days very few people sign their plugins, and I know I'm downloading it from a reliable source. I'll go ahead and restart Eclipse, and now my new version of Eclipse will include the EclEmma plugin in addition to the previously installed plugins like CheckStyle, PMD, and FindBugs. Now to use this plugin, there's this new button here, which is for coverage analysis. It's just like the other run buttons, the standard run button, the external tool run button, and the debug run button. If I open up the homework 0 answer key that I gave you and browse it, you will see in it the implementation of model, but also a set of unit tests that I've written here. Any one of those I could run by simply clicking on it and asking it to run it as a unit test using the run button, or by running the entire package. I would run all tests in that package. If I run it that way, it would look like this, and it will run all tests in the homework 0 package. It looks like at the moment one of my functions is failing, but all the others passed. So 35 runs ran and 1 failed. And when 1 fails, I can jump to the line in question. Now this is a new empty template test that I've written or had generated for me, and it says it should fail, so that's to be expected. Now knowing that 34 or 35 tests pass says one thing, but it doesn't say exactly how good your tests are or how much of the code you have tested, and that's the whole point of coverage analysis. Using coverage analysis, we can run the exact same unit test, but this time the tool will measure how much of the code we've actually touched and exercised. By browsing the coverage window that appears down here at the bottom and drilling down into the architecture, we can see what percentage of, by default, instructions are covered by the code coverage analysis. Covered instructions is listed here, and total instructions is listed here. So as you can see, the test classes themselves have nearly 100% code coverage. The only places where you don't see full code coverage is, for example, here in test contains. It was not completely covered because it failed. That's of no surprise. And in bag test, there's a few lines of code that aren't being covered here due to a variety of reasons. The code coverage analysis we actually care about is the API that we're covering, that is to say the model package itself. And as you can see, the code coverage here ranges from around 87% to as low as 59. By drilling down into the ones that are low, we can discover which methods are highly tested, like all of these, which are very important, and those that are not tested at all. I've written no test, for example, for various toStrings methods. So those are the ones that are particularly contributing to these low performance on some tests. If we pull up the toString, we see it's all in red, which means it was never called during testing. Likewise, the equals method, all the green lines were executed during testing, but the red ones were never called during testing, and the yellow ones were only partially executed during testing. Typically you see partial execution in the presence of conditionals or in the presence of big conjunctions of, for example, AND operators and OR operators. So that gives you a feeling for how you can perform coverage testing. If you want to have full coverage of an architecture, know that your tests are good, you should aim for a percentage of something on the order of 85 or 90%. Were I to write tests for these two-string methods, I would pretty much hit that fairly quickly. We can perform coverage testing of other pieces. Homework 1 is being given back to you imminently. The answer key. I can drill down into it, and it too has a set of tests. I can run those as coverage analysis, so I'll cover as JUnit test. And it runs those as well. 20 tests ran, 20 passed, and if I then look at the coverage for homework 1 and its core implementation, that is to say automata, I see I cover 60% of its implementation. Again, the ones that are not covered are the ones that are unsurprising. For example, two-string and the like. So that gives you a feeling for how code coverage analysis works and what you should aim for. In general, all the run configurations that you add here automatically appear over here, and if you push either button, it will rerun the existing code coverage. Just like in JUnit, you can push this button to rerun your tests and the like. So that's code coverage analysis in a nutshell. Have fun with it, and don't forget to pay attention to it, because it does tell you very useful things about the quality of your tests in your architecture.